2020 National Electrical Code, Section 680.21, addresses raceways for service conductors, stating that service conductors must be installed in a raceway, cable tray, or other approved means. The raceway options include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid non-metallic conduit, or cable tray. Section 680.31 covers overcurrent protection, with subsection A providing a general overview, stating that overcurrent protection shall be provided in accordance with Article 240. Subsection B addresses ungrounded conductors, specifying that where the service conductors are ungrounded, an overcurrent device must be installed in each ungrounded service conductor. Subsection C pertains to receptacles and similar loads that are part of the service, requiring them to be protected by overcurrent protection in accordance with Article 210. Section 680.55 focuses on subpanels, with subsection A detailing load calculation, stating that the load on a subpanel must be calculated in accordance with Article 220. Subsection B covers overcurrent protection, mandating that each subpanel be protected by an overcurrent device rated not greater than the ampacity of the feeder conductors. Subsection C addresses marking, requiring each subpanel to be marked with the maximum allowable load in amps. Based on these NEC sections, the feeder from the main service to the subpanel that feeds pool equipment must be installed in a conduit. This requirement stems from the mandate that service conductors must be installed in a raceway, and conduit is an approved type of raceway. Given that the pool panel is not currently on the riser diagram and will be added, it's crucial to ensure that the overcurrent protection for the pool panel is included in the updated riser diagram. Furthermore, the load on the pool panel must be calculated in accordance with Article 220 of the NEC. The pool panel must be protected by an overcurrent device with a rating no greater than the ampacity of the feeder conductors. Finally, the pool panel needs to be clearly marked with the maximum allowable load in amps. This ensures safety and compliance with the electrical codes. Properly grounding and bonding all metallic parts of the pool and associated equipment is crucial for preventing electrical shock hazards. This includes the pool structure, pump motors, lighting fixtures, and any other metal components within a specified distance of the pool. The grounding and bonding system must be interconnected to form a low impedance path for fault current to return to the source, tripping the overcurrent protection device and disconnecting the circuit. The NEC provides detailed requirements for grounding and bonding of swimming pools in Article 680. Equipotential bonding is a key concept in pool electrical safety. It involves connecting all metallic parts within the vicinity of the pool to create an electrically common surface, minimizing voltage gradients and reducing the risk of shock. This includes bonding the pool reinforcing steel, metal fittings, pump housings, and any other conductive elements within the specified bonding zone. The bonding conductors must be sized according to the NEC requirements and properly connected to ensure a reliable electrical connection. Ground fault circuit interrupter, or GFCI, protection is essential for receptacles and electrical equipment installed near swimming pools. GFCIs are designed to detect small imbalances in current flow, indicating a potential ground fault, and quickly de-energize the circuit to prevent electrical shock. The NEC requires GFCI protection for receptacles within a certain distance of the pool, as well as for specific types of pool equipment such as pump motors and underwater lighting. Regular testing of GFCIs is recommended to ensure they are functioning properly. Underwater lighting in swimming pools presents unique electrical safety challenges. The NEC specifies requirements for the installation and wiring of underwater lighting fixtures to minimize the risk of electrical shock. This includes using listed underwater lighting fixtures, proper grounding and bonding, and GFCI protection. Low voltage lighting systems, typically operating at 12 volts, are often used for underwater lighting to further enhance safety. The wiring for underwater lighting must be installed in approved conduits and sealed to prevent water from entering the electrical system. Pool pump motors are a significant electrical load in pool systems, and their installation must comply with the NEC requirements. This includes proper wiring, grounding, and overcurrent protection. Pool pump motors must be protected by DFCIs, and the wiring must be suitable for wet locations. Variable frequency drives, or VFDs, are increasingly used to control pool pump motor speed, improving energy efficiency and reducing noise. When using VFD, it's important to ensure they are properly installed and grounded to minimize electrical interference. Electrical inspections are a critical part of ensuring pool electrical safety. A qualified electrical inspector will verify that the electrical installation complies with the NEC and local codes. This includes inspecting the wiring, grounding, bonding, GFCI protection, and other electrical components. Any deficiencies identified during the inspection must be corrected before the pool is put into service. Regular maintenance of the pool electrical system is essential for maintaining safety and preventing electrical hazards. This includes inspecting the wiring, connections, and equipment for signs of damage or corrosion. GFCI should be tested regularly, and any faulty equipment should be repaired or replaced promptly. It's also important to keep the area around the pool electrical equipment clean and dry to prevent moisture from causing electrical problems. When performing any electrical work on the pool system, it's crucial to disconnect the power supply to prevent electrical shock. Always use properly insulated tools and follow safe electrical work practices. If you are not qualified to perform electrical work, it's best to hire a licensed electrician. Understanding the NEC requirements for pool electrical installations is essential for ensuring the safety of swimmers and preventing electrical hazards. By following the code requirements and implementing proper grounding, bonding, GFCI protection, and other safety measures, you can create a safe and enjoyable pool environment. Remember to consult with a qualified electrician for any electrical work on your pool system. They can provide expert advice and ensure that the installation complies with the NEC and local codes. By taking these precautions, you can minimize the risk of electrical shock and enjoy your pool with peace of mind. Furthermore, it is paramount to consider the specific requirements outlined in the NEC for the placement and installation of electrical equipment near pools. Distances from the pool's edge, both horizontally and vertically, dictate the types of equipment that are permitted and the safety measures required. Receptacles, for instance, must be located at least a certain distance away from the pool's edge and must be GFCI protected. Similarly, lighting fixtures must be installed at appropriate heights and distances to prevent accidental contact by swimmers. Junction boxes and other electrical enclosures must be weatherproof and installed in a manner that prevents water from entering. These spatial considerations are vital for preventing electrical hazards and ensuring the safety of individuals using the pool. The proper selection and installation of wiring methods are also crucial for pool electrical systems. The NEC specifies the types of wiring methods that are permitted for use in and around pools, taking into account the wet and corrosive environment. Conduit is often required to protect wiring from physical damage and moisture. The type of conduit used must be suitable for the specific application, such as rigid metal conduit or rigid non-metallic conduit. Underground wiring must be buried at a sufficient depth to prevent damage from digging or other activities. The wiring must also be properly sized to handle the electrical load of the pool equipment. Overloading the wiring can lead to overheating and potentially cause a fire. The NEC provides tables and calculations for determining the appropriate wire size based on the amperage and distance of the circuit. The selection of appropriate electrical equipment for pool applications is also essential. Pool pumps, filters, heaters, and other equipment must be listed and labeled for their intended use. This ensures that they have been tested and certified to meet safety standards. The equipment must also be properly sized to match the pool's requirements. Using undersized equipment can result in poor performance, while using oversized equipment can waste energy. The equipment must also be installed in accordance with the manufacturer's instructions. This includes providing adequate ventilation and access for maintenance. Regular inspections and testing of pool electrical equipment are necessary to identify and address any potential problems. GFCI should be tested monthly to ensure they are functioning properly. Wiring and connections should be inspected for signs of corrosion or damage. Equipment should be checked for proper operation and any unusual noises or vibrations. Any problems that are identified should be repaired promptly by a qualified electrician. Proper documentation of the pool electrical system is important for maintenance and troubleshooting purposes. This includes maintaining a wiring diagram that shows the location of all electrical components and wiring. It also includes keeping records of inspections, tests, and repairs. This documentation can be helpful for identifying the cause of electrical problems and for ensuring that the system is properly maintained. Educating pool users about electrical safety is also essential. Pool users should be aware of the potential hazards of electricity and water. They should be instructed to stay away from electrical equipment and wiring. They should also be told to report any electrical problems to a qualified electrician. Signs should be posted around the pool to remind users of electrical safety precautions. The NEC is a complex and comprehensive document, and it is important to stay up to date with the latest revisions. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to consult with a qualified electrician or electrical inspector to ensure that your pool electrical system complies with the current NEC requirements. In addition to the NEC, there may be local codes and regulations that apply to pool electrical systems. These codes may be more stringent than the NEC requirements. It is important to check with your local building department to determine the applicable codes and regulations. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector for specific recommendations regarding your pool electrical system. Improperly installed or maintained electrical systems can be dangerous and can result in electrical shock, fire, or other hazards. By following the NEC requirements and implementing proper safety measures, you can create a safe and enjoyable pool environment for yourself, your family, and your friends. Ignoring these crucial electrical details around a pool can be detrimental and dangerous to all users. Do not take a chance on safety when it involves electricity and water.